What if the night sky is not eternal? What if the stars themselves have not always been there, but were born from a single, fiery breath? This was the unsettling question that began to take shape in the early decades of the 20th century. When the heavens were first measured with new eyes, in the silence of observatories, Edwin Hubble turned his telescope toward the faint smudges of distant galaxies. What he found was staggering. These galaxies were not fixed upon the dark dome, as once believed. They were rushing away, carried by a hidden tide. The fabric of the universe itself was stretching, as though space were alive, with every observation. Hubble revealed a truth that shattered millennia of human assumption. The cosmos was not eternal and unchanging. It had a beginning, but a beginning to everything posed a deeper paradox. If galaxies were once closer together, pressed into a state beyond imagination, then the universe must have erupted from a single, incomprehensible moment. A Belgian priest and physicist, Georges Lemaître, dared to call it the primeval atom, a cosmic egg, exploding into all that is. Many dismissed it at first. The idea of a universe with a birth offended the comfort of permanence, yet nature left its own testimony. In 1965, two radio engineers, Arnaud Penzias and Robert Wilson, discovered a faint hiss in their antenna glow that came from every corner of the sky. It was the afterglow of creation itself, the cosmic microwave background, a relic from when the newborn universe was only 380,000 years old. The debate between steady state and hot Big Bang dissolved under this evidence. Science reluctantly embraced a beginning, and with that acceptance emerged a haunting silence. If time and space truly began in a single instant, what if anything existed before the dawn? The human mind has always lived in the rhythm of cause and effect. A seed falls into soil, and a tree rises. The sun sets, and darkness follows. Every moment feels like a chain of links, each joined to the next. It is a comfort that shapes our understanding of the world. Every event must have a cause. Every beginning a reason, every story a first page. But when science turned its gaze toward the birth of the universe itself, this ancient rhythm began to tremble. For the Big Bang does not merely challenge human imagination, it unsettles the very structure of causality, the bedrock of all experience. To ask what came before the universe is to step into a paradox where the very language of before dissolves. Einstein's equations, those precise symphonies of space-time, are the first to betray this comfort. In the hands of cosmologists, his general theory of relativity became a telescope into the deepest past. When the mathematics are followed backward, when the expansion of galaxies is rewound like film spooling in reverse, all paths converge upon a single catastrophic point, a singularity. This singularity is not a point in space, as one might imagine, not a star or a planet, but a state where the density of the universe grows without bound. All the matter and energy, every atom that would one day become oceans, mountains, and living creatures, compressed into an infinitesimal core. Space itself curves to the breaking point. Time itself grinds toward nothingness. It is here, in this abyss of infinite density, that physics collapses under its own weight. The equations reach values that defy meaning numbers without interpretation, infinities stacked upon infinities. General relativity, the most trusted map of the cosmos, loses its power at the very instant it is most needed. It cannot tell what lies at zero, cannot describe a before. Stephen Hawking once likened this problem to geography. To ask what existed before the Big Bang, he said, is like asking what lies north of the North Pole. The concept itself is misplaced, a question that assumes a landscape where none exists. If time itself began at the Big Bang, then there is no before to speak of. The fabric of chronology, the flow that carries all causes into effects, had not yet been woven. This suggestion is more than unsettling. It is almost unbearable, for it strips away the human instinct to imagine a beginning behind the beginning, a source behind the source. If the Big Bang is the origin of time, then the universe did not emerge into a stage that already existed. The stage itself was born in that same explosion. It was no waiting chamber of nothingness, no silent void stretching into eternity. The clock itself was created with the first tick. Here lies the scientific shock, a beginning without a cause, an eruption without a before. To the human mind, trained by survival to track cause and consequence, this is an affront to reason.
How?
Can something come from nothing? How can time itself ignite? For centuries, philosophy wrestled with these questions in the shadows of myth and metaphysics. But physics, now armed with equations and telescopes, is forced to confront them with cold evidence. The universe is expanding. The radiation of the cosmic microwave background proves a hot, dense birth. The galaxies themselves bear the imprint of a violent origin. There is no avoiding the conclusion. The universe has a beginning, and yet the very notion of beginning fractures under the pressure of Einstein's mathematics. Common sense insists on a before, a spark that lit the fire. Relativity whispers otherwise, that time is not infinite in both directions, that the river of moments emerges from a spring that cannot be traced further upstream. The contradiction is profound. On one side lies human intuition, evolved in forests and savannas, where every sound had a source, every ripple a cause. On the other side lies the raw architecture of the cosmos, in which time itself may not extend beyond a boundary. The clash is almost unbearable. Nature appears to deny the very logic with which humanity interprets reality. Cosmologists, staring into this abyss, faced a crisis not only of science but of imagination. For how can theories be built when the foundation of time itself crumbles? How can equations describe a moment when the very axes of space and duration have not yet been drawn? The singularity is not merely a point of ignorance, it is a wall, beyond which our mathematics cannot pass. This wall does not merely obscure the past, it radiates forward, casting shadows upon our understanding of the present. If causality is not absolute at the birth of the universe, if events can emerge without antecedents, then the principle of reason itself is shaken. Perhaps the laws that govern galaxies and atoms are contingent, emerging only after the Big Bang, not eternal, but born alongside the cosmos itself. And so, science is confronted with a thought both magnificent and terrifying, that the universe might not have a before, but the human instinct to demand a first cause is itself a relic of evolution, as a useful survival tool, but one that breaks when applied to the origin of everything. This realization is not easily embraced. Even great physicists wrestled with its implications. Some clung to the idea of cycles, universes collapsing and reborn, each Big Bang the echo of a prior cosmos. Others leaned toward the strange seas of quantum mechanics, where fluctuations in a void might birth realities without cause. Yet in every case, the singularity looms as a frontier, the place where certainty dissolves. The scientific shock, then, is not merely the discovery of a beginning, but the recognition that beginnings themselves may have no deeper anchor. Time may be finite, space may have an edge in its past, and the cosmos, in all its majesty, may rise from a silence where even silence itself had no meaning. In the immensity of this paradox, humanity is left with an image both humbling and inspiring, that the universe, with its galaxies and suns, its planets and seas, its lives and civilizations, emerged without precedent. That it is not a continuation of something else, but the raw dawn of all existence. And in that thought lies the greatest fracture between common sense and the cosmos. For while the human heart longs for continuity, while the mind aches for a cause, physics whispers of a truth, stranger still, that timelessness itself may be the origin of time. The singularity is not only a frontier of mathematics, is a wound in the fabric of knowledge. For when the universe is rewound to its first fraction of a second, the trusted language of general relativity collapses. Equations so capable of describing the sweep of galaxies and the bending of starlight falter at the moment of origin. They do not reveal what came before. They reveal only infinity, the signal of their own breakdown. Physicists call this the singularity, a state of infinite density and infinite curvature, where the known laws of nature spiral into contradiction. It is not a place one can imagine, not a speck in space, but a condition where space itself ceases to be meaningful. At this point, the mathematics of relativity ceases to guide. To step closer to the beginning, science must call upon another language, quantum mechanics. Here lies the great rivalry of modern physics. Relativity describes the cosmos on its grandest scales, the sweep of galaxies, the orbits of planets, the dance of gravity across the heavens. Quantum mechanics, by contrast, governs the smallest of realms, the flickering world of particles and forces, where uncertainty reigns and probability defines existence. Each is complete within its own domain, and each has been tested to exquisite precision. But at the singularity, the point where the entire universe is compressed to scales smaller than the atom, both must speak together, and yet they do not. Instead, they clash. Relativity insists on smooth curvature. Quantum mechanics insists on restless uncertainty. Where one predicts infinity, the other predicts chaos. This collision of frameworks means that at the very instant of the Big Bang, the laws of physics as we know them dissolve. The universe is born in a place beyond equations. Physicists have tried to push deeper, to carve a path into this forbidden interval. They have named its threshold, the Planck time, 10 to the minus 43 seconds after the Big Bang. A number so vanishingly small, it defies ordinary imagination. It marks the boundary where quantum effects of gravity can no longer be ignored, where space-time itself becomes foamy, flickering, unpredictable. Before the Planck time, our theories cannot speak with clarity. After it, the universe begins to unfold in ways we can trace. Yet even this fleeting instant is enough to raise new mysteries. In that heartbeat after the Planck era, the universe does something astonishing. It does not merely expand. It explodes in size, faster than light, swelling from subatomic scales to cosmic immensity in less than a trillionth of a second. Is inflation the bold idea introduced by physicist Alan Guth in 1980? Inflation proposes that in the earliest moment, the universe was driven by a strange form of energy locked within the vacuum itself. Under its pressure, space expanded exponentially, doubling in size again and again with furious speed. Mountains of energy released, horizons torn apart, quantum ripples stretched across cosmic distances. When inflation ended, its energy transformed into the matter and radiation that would become galaxies and stars. At first, it seemed like wild speculation. But the universe carries scars that inflation explains with uncanny precision. The distribution of galaxies, the uniformity of the cosmic microwave background, and the tiny fluctuations within it all match the predictions of inflationary theory. NASA's COBE satellite revealed the first faint irregularities in the cosmic microwave background, subtle hot and cold spots, ripples that echoed from the dawn of time. These were the fingerprints of quantum fluctuations, magnified by inflation to scales that would later seed galaxies. Later missions, WMAP in the early 2000s and the Planck satellite a decade later, refined this picture with breathtaking detail. They showed that the universe is astonishingly flat on large scales, a hallmark of inflation. They revealed patterns in the microwave background that align with the predictions of a cosmos stretched in its infancy. Each observation lent weight to the notion that inflation was real, and yet even as inflation explains so much, it deepens the mystery still further. For what ignited inflation? What force switched it on? What brought it to an end, allowing the universe to cool and settle into the cosmos we know? The theory describes how inflation works, but not why it began. It is like discovering the motion of a wave, but not the stone that first disturbed the water. Some physicists suggest that inflation may not have needed a beginning, that quantum fluctuations in a seething vacuum might spontaneously trigger inflation endlessly, giving rise to countless universes, each bubbling into existence. Others propose that inflation may itself be eternal, spawning new cosmic domains, without end. If so, our own universe may be only one among an infinite froth, a single spark in a vast and unknowable multiverse. But these are speculations, reaching beyond the horizon of observation. For even the most advanced satellites, even the most sensitive detectors, cannot see before the moment when the cosmic microwave background was released. 380,000 years after the Big Bang, the earlier moments, the Planck epoch, and the inflationary burst are hidden behind a veil of radiation. We reconstruct them not by direct sight, but by tracing the patterns left behind, by decoding the whispers of ancient light. In this effort, science is like an archaeologist sifting through fragments of pottery, reconstructing a vanished world. From shards, galaxies we see today, the background radiation, the isotopes scattered through the stars all are relics of that primordial eruption. From them, cosmologists weave a story of origins, yet the central question lingers, unbroken. Even if inflation describes the swelling of the universe, what lit the spark that began it? What force animated the vacuum? What symmetry broke? What field tipped into instability? If inflation is the engine, what turned the key? Here the investigation runs into its deepest shadow. For perhaps the spark cannot be described by physics alone. Perhaps it lies in the quantum fabric of nothingness, where probability itself allows universes to appear. Or perhaps it is forever hidden, locked beyond the reach of any measurement. The deeper science looks, the more profound the mystery becomes. The singularity shows the failure of our greatest theories. The Planck time reveals the fragility of space-time itself. Inflation explains the growth of the universe, yet hides the reason it began. Each layer of understanding uncovers another veil, another silence, and so. The investigation into the origin of everything does not close the question. It opens it wider, stretching the imagination into realms where the line between science and philosophy grows thin. The universe is not merely vast in space. It is vast in mystery, and at its heart lies a haunting truth, even as science maps the first instance after the Big Bang. The flame that first lit the cosmos still burns unseen. Nothingness. The very word suggests silence, stillness, emptiness. Yet in the language of modern physics, nothing is not so simple. What once seemed like an absolute void is revealed to be something far stranger, a paradox that deepens. The closer one looks, quantum theory whispers a disquieting truth. Emptiness is unstable. Even in the absence of matter, even in the absence of light, space itself refuses to remain silent. On the tiniest scales, the vacuum trembles with activity. Particles and antiparticles flash into existence, dance for a fleeting instant, then vanish. This restless flicker is not imagination, not philosophy, but measurable fact. These fleeting entities are known as virtual particles, and though they cannot be seen directly, their fingerprints appear across the cosmos. They tug on the orbits of electrons, shift the colors of spectral lines, and alter the magnetic properties of empty space. In laboratories on Earth, their effects are confirmed through the Casimir effect, where two uncharged metal plates placed close together feel a subtle force, as though the vacuum between them is pushing and pulling. It is the weight of nothing, pressing into reality. This revelation is unsettling, for it means that the vacuum is not empty at all. It is a seething foam, a quantum ocean where possibility is never still. What human language calls nothing is, in physics, it's a field of infinite potential. And this instability does not merely haunt the microscopic world. On cosmic scales, it reemerges in the form of dark energy, the most mysterious force yet. Detected in the late 1990s, astronomers studying distant supernova made a shocking discovery. The expansion of the universe is not slowing down under gravity's pull. It is accelerating. The galaxies are rushing apart faster and faster, as though pushed by a hidden pressure woven into space itself. This accelerating expansion is attributed to dark energy, a form of energy inherent to the vacuum. Unlike matter or radiation, it does not dilute as the universe grows. Instead, its density remains constant, so that as space expands, more vacuum forms, and with it, more dark energy. It is as though the universe carries within it an engine that strengthens as it grows. A paradoxical fuel drawn from emptiness itself, dark energy now dominates the cosmos. Accounting for nearly 70% of all that exists, its nature remains. Elusive, but its presence is undeniable. The night sky, once thought to be governed solely by gravity's embrace, is instead ruled by the repulsive force of the vacuum. The implications are profound and unsettling. If even the void carries energy, then perhaps universes themselves may be born from it. Quantum cosmology suggests that fluctuations of the vacuum could, in rare moments, grow into entire realities. A tiny bubble of space, inflating under its own energy, could become a cosmos with galaxies and stars. In this vision, universes are not singular miracles, but endless possibilities arising from the instability of nothingness. This is the frightening scale of the paradox. If the vacuum itself is restless, then creation may be inevitable. The universe may not be unique. Reality itself may be a froth of bubbles, each a cosmos, expanding and vanishing, infinite and uncountable. For cosmologists, this realization is both exhilarating and humbling. It forces the abandonment of the old vision of a pristine void. Nothingness, it seems, cannot exist. The vacuum is not an absence, but a field. Not silence, but a murmur. Not void, but potential. Even in its lowest state, it carries the seeds of creation. This leads to a haunting question. Was there ever a true void? Or has nothing always been an illusion, a word for something that cannot, in fact, exist? If every absence conceals a presence, if every vacuum conceals an energy, then the universe did not emerge from nothing. It emerged from a sea that never was truly empty. Philosophically, this strikes at the heart of human imagination. For when people say nothing, they imagine a blankness, a clean slate, a silence, but physics denies this possibility. Every vacuum hums with quantum fields. Every darkness carries fluctuations. The laws of nature do not permit a canvas without texture. This realization intensifies the mystery rather than resolving it. For if nothingness is unstable, if emptiness is impossible, then what does it mean to speak of a beginning? Did the Big Bang erupt from nothing at all, or from a vacuum already rich with hidden potential? Some physicists go further still. They imagine the vacuum as a false equilibrium, like a ball balanced precariously on a hilltop. The universe may have been born when this balance tipped, when the vacuum decayed into a more stable state, releasing its energy in a cataclysmic expansion. In this picture, our cosmos is only one of many possible outcomes, one descent among infinite ridges and valleys in the landscape of quantum fields. This view is unsettling, for it suggests impermanence even in what seems stable. If our vacuum is not the deepest possible state, it too may one day decay. A bubble of lower energy vacuum could appear, spreading at the speed of light, rewriting the laws of physics as it passes. In such a future, atoms would dissolve, stars would collapse, chemistry would vanish. Existence itself would be redefined, though such a possibility is purely theoretical. It hangs over cosmology as a reminder of the precariousness of reality. If universes can emerge from vacuum fluctuations, they can also end by them. The same instability that creates worlds can unmake them, the deeper paradox of nothingness, and is not absence, but abundance. The vacuum is alive with possibility, unpredictable, inexhaustible. It is not the canvas upon which the universe is painted, but the restless loom from which universes are woven. And so, the question that once seemed simple, what existed before the Big Bang, becomes more elusive the closer one approaches. For the answer may be that there was never nothing, that emptiness is an illusion, that the void is full. The silence is always singing, the mystery deepens, not in spite of science, but because of it. Every new discovery, virtual particles, the Casimir effect, dark energy, the accelerating cosmos adds weight to the paradox. The more precisely physics describes the vacuum, the more unstable, the more restless, the more creative it becomes. It is a revelation both magnificent and disturbing, for it suggests that the deepest truth of reality is not stability, but fluctuation. It's not permanence, but emergence. The universe itself is proof of this, a cosmos born from instability, a vast order rising from restless fields. And yet, even in the light of these discoveries, the ultimate question remains unanswered. If nothingness is impossible, if even the void is alive, then what lies beneath? What ground, if any, supports the restless sea? Is there a true foundation, or is reality infinite regress, each layer of nothing revealed as something deeper still? Cosmology has no final word. It gazes into the darkness, measures the whispers of ancient radiation, and constructs models of universes that bloom and collapse. But beyond the data lies silence. Not the silence of emptiness, but the silence of mystery. For perhaps the void itself is eternal. Or perhaps there is no such thing as void at all. In this realization, humanity confronts a truth more unsettling than the singularity, more profound than inflation, more haunting than the expansion of the cosmos, that nothingness, the simplest of all concepts, may not exist. The search for beginnings always returns to silence, a silence filled not with answers, but with visions. When mathematics reaches its limit, and telescopes can no longer pierce the veil of the early universe, imagination guided by theory, disciplined by data steps forward, these are not fantasies, but rigorous speculations, each an attempt to reconcile what we know with what remains hidden. They are the stories science dares to tell when confronted with the greatest mystery of all, how something emerges from nothing. 1. The story imagines a universe without a true beginning, a cosmos that beats like a heart, expanding and collapsing across eternity. In the cyclic or oscillatory model, the Big Bang is not unique. It is one pulse among many. In this vision, the universe swells outward under the force of its birth. But gravity, eternal and patient, eventually halts the expansion, over unthinkable. Spans of time, galaxies slow, stars fade, and the cosmos begins to contract. Inward it falls, drawn back into a crushing convergence, Big Crunch. And from that collapse, a new eruption may ignite, another Big Bang, another expansion, a new age of stars. The idea has deep roots, comforting in its rhythm. It removes the sharp edge of a singular beginning. No need to ask what came before, for there was always another universe, and there always will be. But this story carries its own fragility. Modern evidence of dark energy, with its accelerating push, suggests that expansion may never reverse. If the cosmos continues to speed outward, then the cycle is broken, and the dream of eternal rebirth fades into silence. Yet some physicists keep the vision alive through other frameworks, imagining universes born not from collapse but from collision's vast membranes. Higher dimensional brains crashing in a greater unseen space, each impact releasing a universe like sparks from a cosmic forge. Another speculation arises not from geometry, but from the restless laws of quantum mechanics. In the quantum view, the universe itself may be a fluctuation, born spontaneously from the seething uncertainty of the vacuum. Just as particles flicker into existence in empty space, appearing and vanishing without cause, perhaps the cosmos itself could emerge in the same way, its birth not ordained, but permitted. Here, the Big Bang is not a miracle, but a probability, one outcome among infinite chances. If this is true, then creation is not a question of why, but of inevitability. Given enough time, given enough vacuum, universes must appear. The beauty of this idea lies in its symmetry with quantum law. If uncertainty governs the smallest scales of reality, why not the largest? Yet it is a vision that unsettles the human mind, for it strips away purpose, causality, and design. The cosmos, in this story, does not need a reason to exist. It simply arises as naturally as particles shimmer and vanish in the void. But some theories attempt to erase the very paradox of beginnings altogether. In the 1980s, James Hartle and Stephen Hawking introduced what they called the no-boundary proposal. According to their mathematics, time itself may not have started with a singular instant. Instead, near the origin, time transitions smoothly into something else, another dimension. Curved like the surface of the Earth. On this curved surface, there is no sharp edge, no boundary, no first moment. Imagine walking north on Earth. Step by step, the direction remains clear, until finally the North Pole is reached. Beyond it, north loses meaning. There is no further, the no boundary. Models suggest that time behaves the same way. The universe has no before, no singular creation. It is finite, yet unbounded, existing without the need for a cause. This vision is elegant. It's dissolving the paradox with geometry rather than with force. It suggests that the very question of what came before is misplaced, an illusion born of linear thinking applied where it does not belong. If the no-boundary model is true, then the universe is self-contained. It has no edge, no origin beyond itself. It simply is. Yet the most audacious speculation of all is that our universe is not alone, that the Big Bang was not the birth of everything, but only the swelling of a single bubble in an infinite sea. In this multiverse vision, inflation is eternal. As one bubble inflates into a cosmos, others form elsewhere, each sealed off from the rest, each governed by its own laws of physics, its own constants, its own possibilities. The implications are staggering. If the multiverse exists, then every possibility is realized. Some universes collapse within instants, others last for eons. Some permit galaxies, chemistry, and life. Others are barren, ruled by constants, hostile to complexity. Our universe, with its delicate balance that allows stars and carbon and minds, may not be unique or special. It may simply be one of the rare domains where conditions align. This vision is humbling, but it is also troubling. For if other universes exist beyond our horizon, beyond any possibility of measurement, can the idea ever be proven? Is the multiverse a scientific theory or a philosophical necessity invoked to explain what cannot otherwise be explained? For now it remains a possibility written in equations. It's visible only as shadows cast upon our own cosmos. And then there is the most unsettling speculation of all, that even our vacuum, the apparent ground of reality, may be unstable. This is the theory of false vacuum decay. In quantum field theory, the vacuum may not represent the lowest possible state of energy. Instead, it may be a precarious plateau, metastable, but not permanent. If so, then the universe is perched on a fragile foundation. At any moment, a bubble of lower energy vacuum could form, expanding at the speed of light, rewriting the very laws of physics as it passes. Such a transition would not be a gentle change, but an obliteration. Atoms would unravel, forces would shift, fabric of reality would be remade. Entire galaxies, entire histories would vanish without warning, replaced by a new order indifferent to what came before. Though terrifying, the idea arises not from imagination but from the mathematics of particle physics, from the possibility that the Higgs field, the field that gives particles their mass, may not rest in its absolute lowest energy. Measurements at the Large Hadron Collider suggest that our vacuum could indeed be metastable. So, then the end of our universe may not come from heat death or collapse, but from sudden decay, a quantum catastrophe triggered by the instability of nothingness itself. Each of these theory cycles, quantum fluctuations, no boundary models, multiverse, false vacuum, offers a glimpse into the abyss of beginnings. Each is built from real mathematics, from the scaffolding of observation, from the restless logic of physics pushed to its limits. And each carries both beauty and incompleteness. None provides certainty. All deepen the mystery. Together, they reveal a truth as haunting as it is profound, that the universe may resist final explanation, that origins may not be singular, but manifold, layered, infinite, that nothingness may never have existed, that time may have no edge, that universes may bloom endlessly in the dark. What these speculations share is not closure, but expansion. They widen the horizon of human thought, forcing the imagination to confront scales and possibilities beyond experience. They are not answers so much as reminders that the cosmos is not obliged to conform to intuition, and that reality is always greater than the frameworks built to contain it. And so, the theories of beginnings remain suspended between knowledge and wonder. They do not end the mystery of the Big Bang. They amplify it, going into silence with the same unyielding question. What does it mean to exist when even nothingness itself may be impossible. The birth of the universe lies beyond ordinary reach, hidden in a silence deeper than memory. Yet humanity, fragile and brief-lived, dares to look back, to pry open the curtain of beginnings with instruments forged of glass, metal, and thought. Every telescope, every detector, every collider is a question made solid. They are the hands of science, reaching into the dark for whispers left behind by creation. Today, the James Webb Space Telescope stands as the most ambitious of these eyes. Suspended 1,000,000 miles from Earth, shielded from the sun by a vast silver sail, it gazes outward into ancient light. Webb's mirrors, unfolded like a golden flower, catch photons that have traveled for billions of years, stretched into infrared wavelengths by the expansion of the cosmos. In this light lies the story of cosmic dawn, the first stars igniting, the first galaxies assembling from hydrogen and helium, the first scaffolds of structure that would one day cradle life. But Webb does more than map distant galaxies. By pushing deeper into the past than any instrument before it, it brushes against the very edge of what can be seen. Its gaze reaches to within a few 100 million years of the Big Bang. Beyond that, the universe is opaque, shrouded in the glow of the cosmic microwave background. Yet within this veil lie the imprints of inflation, the fingerprints of how the cosmos expanded in its earliest instance. Webb cannot see them directly, but it narrows the possibilities. Testing models against the architecture of galaxies and the distribution of matter across the void, on another frontier, buried deep beneath the surface of the Earth, lies a different kind of probe, the Large Hadron Collider. Where Webb looks outward across space and time, the collider looks inward, recreating the conditions of the infant universe in bursts of energy between colliding protons. Within its ring, particles smash together at nearly the speed of light, and for an instant, conditions echo those of the first trillionth of a second. It was here, in 2012, that the Higgs boson was discovered, the long-sought particle that confirms the existence of the Higgs field, a field that gives mass to matter itself. This discovery, profound in its own right, carries unsettling implications for cosmology. For measurements of the Higgs suggest that our universe's vacuum may be metastable, balanced precariously on a ridge of energy. If so, it could one day decay, collapsing into a lower state and erasing everything in its path. The collider, by probing the quantum vacuum, is not only uncovering the machinery of matter, but hinting at the fragility of the very fabric on which reality rests. Yet even the collider cannot recreate the Planck epoch, the earliest moment where quantum gravity ruled. To probe that terrain, physicists turn to the faintest relics, the radiation and gravitational waves left behind by inflation. Future experiments, like the Cosmic Microwave Background Stage 4 project, CMBs-4, are designed to measure the ancient afterglow with exquisite precision. In the subtle polarization of this radiation, in patterns called B-modes, scientists hope to find the trace of gravitational waves rippling through the newborn universe. Such a discovery would be nothing less than a direct fingerprint of inflation itself. Confirmation that the cosmos once ballooned outward faster than light. Other instruments listen for whispers even fainter. Gravitational wave detectors LIGO Virgo, in future observatories like LISA and Space Search, not only for the mergers of black holes and neutron stars, but for a background hum, a relic vibration from the first instant of creation. If detected, this cosmic symphony would open a new channel into the beginning, one carried not by light but by the trembling of space-time itself. Still, there are limits that no technology can yet overcome. The cosmic horizon, the boundary defined by the speed of light in the age of the universe, sets an ultimate wall to observation. We can never see beyond it, never glimpse directly what lies outside our bubble of space-time. Nor can we pierce the veil before the cosmic microwave background. When the universe was a glowing plasma opaque to light, this is the paradox of cosmology. To study an event that created time itself, using tools that exist within time, the Big Bang cannot be observed in the ordinary sense, can only be inferred from the relics it left behind from radiation stretched across the sky, from the abundance of elements forged in its fire, from the clustering of galaxies shaped by its expansion. Every measurement is indirect, every conclusion an act of reconstruction. And yet, in this indirectness lies the philosophical courage of physics. For science advances not by certainty, but by daring to test even when the horizon is out of reach. It builds models that stretch beyond observation, then seeks the faintest echoes that might confirm or refute them. Inflation cannot be seen, but its fingerprints may lie in microwave polarization. Quantum gravity cannot be recreated, but its effects may ripple in the earliest structure of the cosmos. The multiverse, perhaps forever beyond observation, may still leave imprints in statistical patterns of cosmic parameters. Each experiment, each telescope, each detector is a wager that reality is coherent, that nature leaves traces even of its most secret acts. It is an act of profound humility and hope, to ask questions that may never be fully answered, and to build instruments anyway, knowing they may bring us one step closer to truth. The struggle is immense. It demands resources, ingenuity, and lifetimes of patience. Webb will peer for decades. Colliders will smash particles by the trillions. Generations of scientists will sift through radiation maps, searching for patterns in the faint glow of the sky, and perhaps none will see the final answer. But science is not only about answers. It is about the pursuit, the refusal to look away from mystery. In this pursuit, the tools of observation are more than machines. They are monuments to curiosity, bridges built across the abyss of unknowing. Each reflects a truth about humanity, that, even in a cosmos vast beyond comprehension, a species of fragile beings, bound to a small world orbiting a small star, can reach outward with questions written into steel and glass. And so, the investigation continues. Webb unfolds its mirrors to catch ancient light. The collider roars beneath the earth, unraveling the quantum fabric. New detectors rise, listening for the hum of creation itself. Each experiment is a conversation with the universe, a question, posed across eternity, but behind the machinery, behind the data, the silence remains. No telescope can yet look beyond time. No collider can recreate the moment before moments. The birth of the universe remains hidden, its first spark concealed. And yet, perhaps this is the essence of science's courage, to confront the impossible, to measure the unmeasurable, to seek the unseeable, to acknowledge that the horizon may never be crossed, and still to walk toward it. For in that walk lies the heart of the human story. A refusal to accept the darkness as final. A belief that even in the silence before time, the universe has left us clues. There is a paradox at the heart of existence. The closer science draws to the moment of beginnings, the less the universe resembles emptiness. What once seemed like void now trembles with quantum fields. What once was thought to be nothing now carries dark energy, virtual particles, and the seeds of galaxies yet unborn. Perhaps nothing never truly existed. Perhaps it cannot. This realization unsettles more than equations. It unsettles the human spirit. For imagination was not built to grapple with timeless voids. Minds evolved in forests and grasslands, shaped by dangers and desires, trained to see causes and effects in the rustle of leaves and the motion of prey. Every sound had a source. Every shadow had a reason. To imagine a beginning without cause, to conceive of time without a before, is to push thought beyond its natural horizon. And yet, it is precisely here that humanity lingers, asking questions that may not have meaning yet must be asked. What does it mean to wonder what existed before time itself? What does it mean to chase the notion of before, when the very fabric of chronology may not allow it? Perhaps such questions are like trying to see beyond the horizon of a sphere, destined always to curve away. But still they are asked. And in asking, something profound emerges. The Big Bang, in this light, may not be the beginning of everything. It may be only the beginning of us. The beginning of a universe in which matter coalesced into stars. Stars forged the elements of life, and life in turn became aware of the stars. The Big Bang is not simply an origin, it is an opening act in a story that includes the observers who now reflect upon it. This recognition is humbling. It places humanity in a universe vast beyond comprehension, where even the question of beginnings may have no answer, or may have answers forever hidden beyond reach. To stand beneath the night sky is to stand before a cosmos that guards its birth with silence. And yet it is in that silence that wonder grows. Perhaps the question is unanswerable. Perhaps there was no void, no nothingness, only a fabric that forever trembles, forever births, forever transforms. Or perhaps there was a moment so alien to comprehension that words like before and after dissolve into irrelevance. Time itself may have curved away from the question, rendering it meaningless, but the act of asking remains. And it is in this act that humanity touches the deepest fabric of reality. The pursuit of origins is not only about physics or cosmology, it is about what it means to be conscious in a universe that hides its beginning. To wonder is itself a kind of participation, a resonance with the mystery that gave rise to stars and seas and thought itself. In this light, the silence before the Big Bang is not empty. It is full of possibility, of humility, of awe. It is a reminder that the universe does not exist to satisfy curiosity, but that curiosity exists because the universe gave rise to beings capable of asking. The paradox of nothingness, the search for origins, the attempt to reach beyond time, these are not failures. They are triumphs of imagination, of a mind daring to press against the boundaries of the possible. And so the final haunting thought lingers. Maybe the question of what came before the Big Bang can never be answered. Maybe it was never meant to be. But in asking, in daring to frame the impossible, humanity does more than seek truth. It becomes part of the mystery itself, woven into the same cosmic fabric it struggles to understand. The universe may never yield its first secret, but in the quiet persistence of the question, the human story is written. Story not of answers, but of wonder. Story that begins, as all stories do, with the unknown.